So what I got here today is a chip on backplane, a cob light, two linear current regulators. I've removed the conformal coating on the one so that I could look up the part number. So you got your rectifier, you've got a resistor of some kind. I know these are current sense resistors, 7R5 each of them, and the third one's not populated. And then your LED array. So I've got it hooked up to a variac, and I have the good old oscilloscope over here as per convention. So over here, channel A is connected across the driver, channel B is connected across the CT, which is the usual CT I've been using in recent videos. So here 1000 to 1 CT, the 1K resistor, 1000 ohm resistor. So for every milliamp we see 1 millivolt. So what we want to do is have a look at the current waveform being drawn through this while it's lit. So for that I've got a variac, a useful tool. We're going to power it up, have a look at the voltage waveform and the current waveform, and then we're going to talk about the linear regulator as well. So here we go. There's the voltage coming up. There's triggering. And yeah, those wires are still apart. So their lamp is coming up. So we at this stage are at 200 volts. It's starting to conduct through the LEDs. So let's keep going. Now this is going to get bright. Let's do that like so. As we get to full voltage, let's put that on hold and turn that down, because I don't have heatsink on this and that needs cooling. So let's have a look at what happened here. So there's our sine wave, and there we can see where it goes into conduction. Now what I actually need to do is swap that around so that the waveforms are in the same polarity. Just a moment, make it safe. Let's remove that probe and that probe, connect it to that one, and of course this probe is twisted. Okay, let's try that again. Let's put our paper back over the lamp, turn the variac on, okay. So there we can see it nicely. As the voltage gets to the point where the LEDs start to conduct, you see the current come up, go down as it regulates, and then as you get below 200 volts the LEDs go out of conduction again. And then over here on the reverse, you see the current go negative, goes to 0, and then you go back into conduction again. It does the same on the negative cycle. So the area where current is being drawn off the mains is only this middle part. So basically you're not going to have the best harmonics or the best power factor out of it, because it's not a linear load. But that's how solid state rectifiers work. And the current's all drawn around this area after about 200 volts on the main cycle. So there you can see the current waveform nicely through the CT. They're fast, so if you're wanting to capture AC current waveforms and you don't have a probe, a CT is your friend for AC. It obviously won't work with DC, but it works beautifully on AC. The cheap form of seeing what's happening on the current side. So that's it over there. You can see what the current waveform looks like for this thing, which is what you'd expect. It's a linear regulator. There's no switch mode stuff going on. It just conducts and current regulates. So therefore, during this portion of the main cycle, you're not getting any light out of the LEDs. But of course, due to persistence in our eyes, it looks like constant light to us. But in the case of cameras, you'll often see strobing because of this area where there's no light emission from the LEDs. So let's bring in the paperwork, turn that off, and make it safe. This is called an RM9003A. We've got this package over here. Let's unplug it totally. Make sure we are completely safe from getting electrons into our body. We don't want that. So there we go. We've got two of them on here, so they each handling half of this panel. It says Ganado fluorescence, bulb, corn lights, candle lights, other small power LED lighting. Output current 5 to 100 milliamps. Now we were seeing, that's 20 millivolts per division, so we were seeing about 40 milliamps in this unit. Right, so we know that we've got they don't describe the package. We've got the 8-pin SOP8. Drain, ground, sense, no connection. There's a very simple thing. Here's the circuit. Got the bridge rectifier, which is that part over there, the 4 pins. Got our LEDs, which is that array over there. Our linear regulator chip, we've got 2 of them over there, and then our sense, which is those 2 over there. And those are CR7 R5s. So you can run them in parallel by doing that. And that is possibly what they're doing over here, running them in parallel. I'll see if they want more light, they can add another one. You'd obviously need more cooling for that. Let's see what else this paperwork contains. I've looked through it. It's a very simple thing. You got there's your FET through which they do the current regulation, your drive-in logic for the gate drive, and your current sensing. That's it. Proposed power chip consumption is less than 1.5 volts watts. The voltage IC is assumed. The bigger the voltage, the greater the loss of IC itself. Yeah, you try to keep the voltage drop across the this FET here to a minimum, because you got IR losses over here, which is heat in the chip. So you're obviously trying to keep that at sensible levels. Over temperature, so at 110 degrees C it gives up. That's sensible. And boil water at that temperature. What else have they got here? This is very straightforward stuff. It's textbook stuff. There's the pin package, the dimensions and stuff. I just printed out the entire document of 8 pages. There's your various packages, and that's it. And over there you can see our waveform, a nice sine wave, which is our main supply, and then that's what the current drawn looks like. Interesting that it does that. That she goes through the goes into the negative half of the cycle briefly, and then goes out of conduction. I'll have to think about that. That's fairly obvious what's going on there, but that's an interesting little quirk over there. But basically you've got a full bridge rectifier supplying it, so that is interesting that it's doing that. I wonder if it's got something to do with the inductive supply, because I'm running it off a variac. That could have something to do with that, because there is some inductance over here, obviously. Not much, because this is an auto transformer. But yeah, very interesting. And there's our friends, the harmonics, and you can see the effect on the current on the regulator because of the harmonics. As per our previous videos, they are present and they are showing up. Ever present harmonics. But that is because I got a soft supply and there's electronic loads present on it, which are unavoidable, but if you keep it to a minimum you get by. You don't have to worry too much about it. I paid about $10 for this. There's a mounting holes, the aluminium plate which you're supposed to stick on a heatsink, and you can build yourself a light. There's quite a good amount of light that comes off it. What did we say? 200 volts at 40 milliamps. Let's work it out. I have a calculation device over here. So it's 200 volts times 0.04 amps equals 8 watts. Yeah, that sounds about right. So there we have it. Yeah, maybe you can see it, maybe not. I hope so. Okay. So we worked out the power. So it's about 8 to 10 watts. You're probably going up to 220, 240. So that'll be about 10 watts that we're getting off there, which, given the physical size of the array, I would agree with that. About 10 watts of light. So that's nice if one wants to build oneself a little custom light fixture. One can design your own enclosure, you obviously need cooling for it. You can 3D print a nice diffuser over it, or build it into an existing fitting or something. And that's it. I've been waiting for a while to play with these because I was waiting on a variac, so now we have a variac on the bench and we can have fun with these types of things. I wasn't sure of the supply voltage, which is why I wanted to run it off a variac before assuming that it's 220 volts mains rated. I didn't want to start an electrical fire here. Obviously that makes for compelling YouTube content when you start an electrical fire with the camera rolling, but it's not something that I intend to do on this channel. It's not the aim of the videos. There are channels that do that. This is not one of them. We try not make things go kapooey here intentionally. This is an educational channel for good reasons. It is there's some entertainment in it, but I try to keep it educational. Anyhow, the rambling needs to stop. So, ladies and gentlemen, have an awesome day further, and I'll see you next time for more interesting stuff, or stories if you prefer that. You're welcome to comment and like. I much appreciate it. So have an awesome day further. Cheers.